In this video, we're going to talk about the fundamental theorem of calculus. This theorem will allow us to find the definite integral easier than computing the Riemann sum. So for this one, it's going to consist of two parts. Let f be a continuous function on the interval a, b. We're going to define function g by we have gx equal to integral from a to x of ft dt. So you can imagine your function g as the area under the curve y equal to ft from a to x. So this one is your gx. Okay, so the area is equal to gx. And you have gx equal to integral from a to x of ft dt, so it's going to give you this area. The fundamental theorem of calculus part 1 say that this function g will be continuous and it will be differentiable on the interval a, b, and you have g prime x equal to fx. So what does it mean if I write this one? So you see that what is g prime x? Gx is equal to integral from a to b. So you have g prime x is going to be just derivative ddx of integral from a to x of ft dt. And you see that you have diff and integrate. When you have diff and integrate, they will kind of cancel each other. So you end up with only your function fx. So this guy will be equal to fx. Okay, so this one is g prime x equal to fx, and you can imagine this guy as you just differentiate the integral side out. Okay, so this one will be just cancel. Okay, so this one cancel. Okay, so you have only ft left. Okay, so this one, sometimes this guy is called differentiate under the integral sign. Okay, so it's going to be differentiate of the integral sign like this. So in other words, we do have the dx of integral from a to x of ft dt equal to fx. So if you have gx equal to integral from 0 to x of the cubic root of psi t dt, so you have g prime x, so it's going to be just, you see that it look like you're going to differentiate, so you're going to just plug in t with x, so it's going to be the cubic root of psi x. And actually that's it. Okay, so that's all we have to do. For another one, you have gx equal to integrate from x to negative 1 of e to the t squared dt. So you see from the above formula that you have integrate from a to x. Okay, so you have a here and x here. However, you have x down here, you have constant a up here. So this one will be my a. So in this case, you're gonna not be able to apply the formula right away. So you may have to flip this one. I'm gonna just flip this guy. So it's gonna be negative 1 to x e to the t squared dt. This is what we have learned last time about when you like to have the integral from a to b equal to negative of integral from b to a. So you just flip this one. However, when you flip this one, you're going to obtain an extra negative sign. So this is what you get. So you're going to differentiate. So you differentiate g prime x, so it's going to be the extra negative sign, and you see that you're going to just put x to t, so it's going to be e to the x squared. Okay, and the negative sign comes from flipping. That's it. Okay, so the next one will be gx equal to integrate 1 to x of square root t square plus psi t, and you would want to compute g1 and g prime pi. So you see that this one, you have x as variable, and you're gonna plug in x equal to 1. So when you plug in x equal to 1, you would get integrate from 1 to 1. Okay, so you have this one is g1, it's gonna be integrate from 1 to 1 of square root t square plus psi t dt, and you integrate from the same point like I told you last time. You not have any width, the width equal to 0, so you're gonna get equal to 0 for this one. Okay, and for g prime, so it's going to be just you find g prime x, you're going to differentiate, so you're going to have x here and x here, so g prime x will be square root x squared plus psi x. Okay, and so you get g prime pi given by square root pi square plus psi pi. Okay, so it's going to be pi. Okay, so it's going to be pi, psi pi equal to 0, and square root pi square turned out to be pi. The next thing that we're going to study is going to be, can we differentiate under the integral sign by using the chain rule? Of course we can. So what is the chain rule? The chain rule will be, you see the variable and you see ux here. Okay, so you see this is not a function in x. So this is not x, it is a function in x. So when you differentiate is ft dt, so you have ux here. The way that you have the chain rule will be, it's gonna turn out to be just derivative, and you plug in instead of x, it's gonna be ux. So you're gonna put ux to the place of t. Okay, so you're gonna put ux for the place of t, and also you're gonna put ux for the place of t here. You didn't see this one before because you dip x is gonna be 1, ddx is gonna turn out to be 1. So here you're gonna have fux and ddx of ux. So this one is called the chain rule. Okay, so you're gonna have fux and you're gonna have ddx of ux, and this guy will be play the role of dip inside. Okay, so this guy playing a role of dip inside. Okay, so for this guy, you have gx equal to integral from pi to log x of square root 1 plus t squared dt. So you're gonna have g prime pi, sorry, you like to find g prime x. G prime x will be, you're gonna put t with log x, so it's gonna be square root 1 plus log x square. Okay, and you're gonna differentiate log x. So this guy is the yellow one. Okay, and differentiate log x, you get 1 over x. Okay, so this one is your final answer. The next one, you have gx equal to integrate from psi x to 4 of 5 over 1 plus t cubed dt. So for this one, you see that you must flip the function a little bit in order to have your x on top. So it's going to be negative integral of 4 to psi x of 5 over 1 plus t cubed dt. And for this one, you're gonna have your psi x like this. Okay, and you see that you have the extra minus psi here. okay? And then you're gonna differentiate. So you have g prime x. So you just plug in psi x here. So it's gonna be negative 5 over 1 plus psi x cubed. And you're gonna dip psi, okay? And you dip psi, you get cos. So this is your extra term, okay? The next one, you have gx equal to integrate from x squared to arctan x of psi 3 minus square root t plus 1 dt, and you would want g prime 0. So in this case, you see that you have x on top and x on the bottom. Okay, so you have both x on top and on the bottom. You'd not be able to differentiate this function right away because the bottom guy must be constant and the top guy must be variable. So the first thing that we're gonna do for this example will be we're gonna split. Okay, so this one will be your first step. The first step will be you're gonna split this one. So it must be integral from x squared to arctan x. Okay, let me enlarge this one a little bit. So it's going to be integrate from x squared to 0 of psi 3 minus root t plus 1 dt. And it's going to be integrate from 0 to arctan x. And you have psi 3 minus root t plus 1 dt. Okay, so you split this one. You see that you can split at any point. So I choose 0 because of the symbol of 0. So you just split at 1, split at 2. It doesn't matter. It's going to be just any arbitrary constant that will do this job. Okay, so this one you just split at any point. Another thing will be you're gonna flip. Okay, so another step will be you're gonna flip this one. This one is your second step. So you're gonna flip this one. So you see that this guy will be integrated from 0 to x squared together with the negative side. Okay, so you have the negative side and you have psi of 3 minus root 3 plus 1 dt. Okay, and you're gonna add by the same term. Okay, so let me just copy this one down. So this one I just gonna copy it down. Okay, so this one will be just like this. So you have split and you see that if you flip this one, you get extra minus psi. Finally, you're gonna differentiate. So the third step will be you're gonna differentiate this guy. So you're gonna find g prime x. Okay, so after you have your gx, so you're gonna differentiate. So we're gonna differentiate this one. So you see that you have two terms to differentiate. So you may differentiate just term by term. So you just you just plug in t with x squared and t with arctan x. So for this one, let me. So you have your t, you have your t. So it's gonna be negative psi psi 3 plus, not plus, minus square root x squared plus 1. Okay, and you don't forget to differentiate just your x squared plus psi 3 minus square root arc10x plus 1, and you differentiate arc10x. Okay, so you pull out, so you plug in x squared to t, you plug in x squared arc10 to t, okay, and you differentiate your x squared and your arc10, okay, and you know that differentiate x squared, this one will be your 2x, differentiate arc10 is 1 over 1 plus x squared, okay, so you have your g prime x ready. So it's going to be negative psi 3 minus root x squared plus 1, okay, times 2x plus psi 3 minus root arc 10x plus 1, okay, times 1 over 1 plus x squared, okay. And the question asks you to find g prime 0. So you're gonna put x equal to 0 into g prime. So you have g prime 0. So you see that the first term turned out to be 0. So you put x equal to 0 and put x equal to 0, put x equal to 0. The first term turned out to become 0. Okay. The second term is going to be psi 3 minus square root arc 10 0 plus 1, okay, and 1 over 1 plus 0 square, and this guy will be psi of what, 2, okay, so it's going to be psi 2 radian. Okay, so this is how we find the derivative of the integral sign. Okay, the next one will be if you have to find the definite integral from a to b of fx dx. Okay, so if you want to find the integral from a to b of fx dx, you have the function f that will be the antiderivative of your small f. So you have your capital F be a function such that f prime x equal to the small fx. You're gonna be able to compute the antiderivative, not antiderivative, the integral from a to b of fx dx is gonna be just your antiderivative. So it's gonna be fx, and it's gonna be f, the capital Fx, and you're gonna plug in x equal to b subtract by x equal to a. Okay, so this is I'm gonna explain why this one is correct. Okay, so let's see what's going on. So you have integral. Yeah. You know that you have integral from a to b of fx dx, okay, equal to integral from what? Integral from a to c of fx dx plus integral from c to b of fx dx. Okay, so this is what we have so far. And you see that if I flip this one a little bit, I'm gonna get integral from a to c of fx dx plus integral from c to b. I wrote it wrong, so it's gonna be from c to a and c to b of fx dx. Okay, so this is what we have, right? However, you see that if we let the capital Ft equal to integrate from c to t of fx dx. Okay, so if we let the capital Ft to be integral from c to t of fx dx, then you're gonna differentiate for me. F prime t equal to what? F prime t equal to, you just have ft. Okay, so you have f is an antiderivative of the small f. Okay, and you see that integral from a to b of fx dx, this guy, you see the yellow one first. The yellow one here turned out to be what? Turned out to be negative of capital FA. Okay, because you just plug in t equal to a, and the second one turned out to be plus FB. Okay, so you plug in t equal to b. So this is how we obtain the formula. Okay, so we're gonna read this one as, so this guy will be antiderivative, right? Antiderivative. How could we get antiderivative? It's going to be just integrate by the thing that we have studied earlier. And this one is going to be, b is going to be upper limit. So this one is called upper limit. And a here will be lower limit. Okay, so this is the thing that we have. So in order to compute integral from a to b, it's going to consist of two steps. The first step will be you're going to integrate to obtain the antiderivative, the capital F. And the second step will be you're going to just plug in the upper limit, subtract by plugging in the lower limit. Okay, I do many examples after this. So for this one, you like to compute integrate 0 to pi over 4 of cos x dx. So for this one, you see that first of all, the first step will be you're gonna integrate. You integrate cos, okay? So the first step you integrate. Okay. So you integrate cos, you would get sine x. Okay, and you're gonna draw a bar and you're gonna say x equal to 0, x equal to pi over 4. Okay, so that's my first step. My second step is gonna be you're gonna compute upper, subtract by lower. Okay, so it's gonna be sine pi over 4 subtract by sine of 0. So in this case, it's going to be, what is sine pi over 4? Sine pi over 4 is root 2 over 2, and sine 0 equal to 0. So it's minus 0. So it's going to be just root 2 over 2. Okay, so it's going to be just root 2 over 2. Okay. The thing that, the next one we have integral from 1 to 4 of square root x plus 2 dx. So for this one, you're gonna integrate square root x. Square root x is x to the 1/2. Okay, so you're gonna just have x to the 1/2 plus 1 over 1/2 plus 1. Okay, and you integrate 2, you get 2x from x equal to 1 to x equal to 4. So this guy will be x to the 3/2 times 2/3 plus 2x. okay, from 1 to 4. So this guy will be 4, not 4, 2/3 first. 2/3, 4x 4 to the 3/2 plus 2 times 4 minus 2/3, 1 to the 3/2 plus 2 times 1. Okay, so you would get 4, right? So it's going to be 4, 8, 16. Okay, so it's going to be, this term will be 8. So this guy will be, let me compute this one. So it's going to be 16 over 3 plus 8 minus 2/3 minus 2. Okay, and this guy will be how much? I believe that it will be 40 minus 8. Okay, so it's going to be 32. So this guy will be 32 over 3. Okay, so that's all. The next one, you want to integrate from negative 1 to 0 of e to the x plus 3 to the x. So you basically integrate e to the x is e to the x, integrate 3 to the x is going to be 3 to the x, and don't forget over log 3 from negative 1 to 0. And this one will become e to the 0 plus 3 to the 0 over log 3, one term, minus e to the negative 1 plus 3 to the negative 1 over log 3, another term. So this one would be 1, okay? And you have 1 over e together, and this term and this term. Okay, so this term and this term is going to be what, 3 to the minus 1, right? So it's going to be 1 minus 1/3, so it's going to be positive 2/3 times 1 over log of 3. Okay, so this one will be number C. For D, okay, for D, you like to integrate from 1 to e square. Okay, so let me hold on a little bit for you may copy down. For D, you have integral from 1 to e square of 1 over x minus 1 over x square. Okay, so for integrate 1 over x is going to be log. Okay, so this guy will be log absolute x, and integrate 1 over x squared here, this guy is x to the negative 2, so it will become x to the negative 1 over negative 1, okay, and it's going to be from 1 to e square. So you get log absolute x plus 1 over x from 1 to e square. So this would be log of e square plus 1 over e square minus log of 1, okay, plus 1 over 1, okay. So in this case, what is log of e square? Log of e square, you pull down 2, so it's going to be 2 log e plus 1 over e square. Log 1 is equal to 0. So you get minus 1. Okay. So it's going to be log e is equal to 1. So it's going to be 2 minus 1. So it's become 1 over 1 plus e square. Okay. So it's going to be 1 plus 1 over e square. Okay. So that my D. For e, you're gonna integrate from 0 to 1/2 of 2x cubed minus 6x. The first two will be just easy. So for this one, it's going to be 2x to the fourth over 4. And this guy is going to be 6x squared over 2. Okay. And the last one, okay, the thing that you have to concern a little bit, this one is a special formula. It's going to be 3 psi, not psi, arc psi x. Okay, so it's going to be 3 arc psi x. So it's going to be from x equal to 0 to x equal to 1/2. So this guy will be 1/2 x to the fourth minus 3x squared, okay, plus 3 arc psi x from x equal to 0 to x equal to 1/2. So you're going to plug in x equal to 1/2, subtract by x equal to 0. So it's going to be 1/2, and you have 1/2 to the fourth minus 3 1/2 square plus 3 arc psi 1/2, okay, minus 0, right? 0 to the fourth, 3 times 0 square plus 3 arc psi 0. So every term here turned out to be equal to 0. So the thing that you may have to concentrate will be just the first 3 terms. So this guy will be 1/2 times, so it's gonna be 1 over 32. Okay, so it's gonna turn out to be 1 over 32. It's 1/2 to the fourth. Okay, and you have 3 over 4. 3 over 4. And you have arc psi 1/2 is pi over 6. So it's going to be plus 3 times pi over 6. Okay. So you get pi over 2 minus, so it's going to be what? It's going to be 32. Okay, so it's going to be 32. And it's going to be 24. So it's going to be 23 over 32. Okay, so this one, you just sum these two fractions. Okay, so you get 23 over 23 over 32. Okay. Let's do the last one. You have your fx. Okay, so you have your fx. Let's read the question a little bit. You have your fx equal to x plus 1 when x between 0 to 2, and 11 minus 2x squared when x between 2 to 3. And the question wants you to find integral from 1 to 3 of fx dx. So in this case, the function is a piecewise function. So you see that you have the blue guy and the yellow guy. So this one, when x between 1 to 3, so you draw a line that gonna tell you you have 1, 2, 3, and you have 0. So you have in the 0 to 2 is going to be the blue color, and for 2 to 3 is going to be the yellow one. Okay, so you see that you like to integrate from 1 to 3, so you may have to split this one. Okay, so you're gonna split this one into integrate from 1 to 2, that you're gonna use the blue color. So it's gonna be x plus 1 dx. And you're gonna add by integrate from 2 to 3 of 11 minus 2x squared dx. So this one is the yellow one. Okay, and this guy is the blue one. Okay, so this is the thing that we have. And then you gonna integrate this one. Okay, so uh, you would get integrate x is going to be x squared over 2 plus x. Okay, so it's going to be from 1 to 2. That's my first term. And my second term will be 11x minus 2 over, not 2 over, sorry. So it's going to be 2, and you have x cubed over 3 from 2 to 3. Okay. So you're going to plug in. So it's going to be 2 square over 2 plus 2 minus 1 square over 2 plus 1 plus 11 times 3 minus 2 times 3 cubed over 3 minus 11 times 2 minus 2 times 2 cubed over 3. Okay, so this is how we have your final answer. Okay, and this one is going to be 2 plus 2. Okay, so it's going to be 2 plus 2 minus 3 over 2. So it's going to be 2 plus 2 minus 3 over 2. And this guy is plus 33. Okay, minus this one is 18. Okay, minus 18 minus 22. Minus 22, plug in x equal to 2, and you're gonna add by 16, right, times 3. Okay, so you see that this one combined together, you would get 37 minus 40, so you get negative 3. Okay, minus 3 over 2 plus 16 over 3. Okay, so you get this number, and you're gonna find the LCM, which is 6, so you get negative 18. Okay, so you get negative 18. You get minus what? Minus 9. Okay, minus, not 9. Okay, it's minus 9 plus 16 over 6. Okay, so this one will be negative 18 minus 9 over 6. Not 16. So this guy will be, sorry, it's gonna be 32. Okay. So you get 32 minus 27. So it's gonna be 5, 6 for your final answer. Okay, so let me check my number again. I get negative 3, right? So it's gonna give 3 half. So it's gonna be, how much do I have? How much do I have? So it's gonna be, okay, so it should be correct, right? So this one is gonna be 3, 4, 4.5, 9 over 4. 9 is gonna be 27. Yeah, negative 27 plus 32. So it's gonna be 5, 6. Okay, so this one will be the thing that called fundamental theorem of calculus, and it's gonna allow us to compute the definite integral easier by just integrate and plug in the value. Okay, so that's it for this video. So, and it's gonna be this section, and I'm gonna end this section.